So hello everyone, today is Monday, January 20th, 2020. And today we have Alan Altmark here to share with us about the 12 pillars of systems management. So with that, I'll turn it over to Alan.
Good day, everybody. This presentation was put together as a result of my working with clients. I'm in lab services, been that way for the last 10 years. And working with clients, I've found that there's a bit of confusion about, oh, I got ZVM, now what? After VM is up and running, what do we need to do with it? These 12 pillars are, okay, I'll admit it, they're rectangles, all right? But there are these areas that we have to look at. And the way I look at these, I go, look, we have to go through all of them. A client, salesperson, all needs to go through all of these to make sure that the customer is going to have a successful experience with ZVM. If they buy ZVM and don't really understand what to do with it and how to manage it, it's just going to be a disaster. And we want all of the deployments to be successful. Typically, this requires spending money. And if a client is unwilling to spend money, that's pretty much a sign that we're going to have trouble. But I wanted to go through all of these areas just to talk about what are the kinds of things that clients need to think about when they're going to deploy ZVM. So the first one is understanding the ZVM hypervisor lifecycle. And, if somebody's really in a hurry to get it deployed, but, you have to stop and think about it. ZVM is an operating system like any other. You must have a process for how do I install it? And after I install it, what's it supposed to look like at my client, in my shop? We don't just install everything from the installation media and start all over necessarily. We might be cloning a system or logically cloning. Might be doing an installation, but I'm supposed to have a configuration guide, for example, that says, this is how the ZVM system should look when I'm done. What does done look like? And that includes, all the customization. What kind of patching model are we going to use? How current in service do we have to be? Even understanding that RSUs aren't really current service. They're a point-in-time service. So making sure that, well, I just have to pay attention to RSUs. No, you need to pay attention to RSUs plus any PTFs that have been delivered through corrective service. And what if you happen to be the lucky person who opens the APAR and has a PTF? Do you understand how to perform fixed test? Because IBM is going to ask to perform fixed test. And so having an environment in which you can do that is appropriate. It doesn't work out really well in general when clients call and say, I have a problem, would you fix it? Yes. Would you test it? No. Those kinds of problems don't really go very far, very fast. So it's an important aspect. And knowing how to do it. And so understanding what is a PSP bucket? Yes, it's an ancient, but it's a venerable part, a respected part of the Z ecosystem. We've had them for decades and they actually work. But people need to know that they exist and they need to pay attention to them. And then when it comes time to upgrade your system, how are you going to do that? We're used to, some clients are still thinking about, even today, I have clients who think about the idea that we have to install brand new systems and move our workload over to it. Or we have to install brand new systems and then copy it, bits and pieces, over to my existing system, which is that's just wrong. We don't do it that way. And then thinking about when I'm done. What happens when I'm done with this LPAR? What happens when I'm moving, I'm consolidating? Maybe I've skipped a few generations of hardware and I've managed to get a nice new machine. Maybe I need one fewer LPAR. Do I have a procedure for how do I end a ZVM system? And all of these things, hypervisor issues, as we'll discuss compared to provisioning, virtual server provisioning, hypervisor lifecycle, those are tasks that you don't really perform very often. So it is important to practice them. And practicing how do you get dumps from the system. If a client asks, what should I do? And I just thought, well, once a quarter, you should do one of these things on your test system. Go through the procedure. When you have that SEV1 problem or that SEV2 problem and IBM sends you a fix and you go, I need to put it on, and you go, I don't know how to do that, that's not the time to tell your boss that you don't know. All right, it's important to practice these things. So when we look at understanding, installation, downloading, and preparing an RSU for installation is actually different than corrective PTFs. The instructions are different for how you download and prepare the files. So assuming that you know one, can't assume you know the other. But understanding the RSU is just selective preventive service PTFs. They are cumulative. The executables are rebuilt automatically, pre-built by IBM. But I will say it's conservative in content. All right, we could have an RSU that's been out there for 18 months, and you say, oh, I'm going to upgrade, I'm going to put the latest RSU on, and you'll find, oh, it doesn't have some SPEs on it. It might not have hardware support, probably will not have your latest hardware support on it. So it's important that we don't assume things about the RSUs. We actually go look, and there's a web page that actually tells you what the content is. And they're conservative because they're meant to be stable. We want people to be able to, without too much thought into it, we would like them to be able to install an RSU, have a good confidence that it's not going to disrupt their system. Corrective service, on the other hand, a particular PTF could be very disruptive to it. It kind of depends on what it is, how old it is. If it's something brand new, something in a complex area, it generates risk. And so be able to do that. This is also how, if you open a PTF, you open an APAR and get a PTF from the support center, and then you're going to need to test it, it's going to show up as a corrective service, as a PTF. If your desire is to be current, you've decided that we need to be within 60 days. IBM comes out with a patch, and we need to be either 30 days, 60 days. Some clients, you got 10 days to put it on, or justify why I'm not, okay? So this need to be current, deciding how current do you have to be drives how much effort you need to spend in managing the service levels on ZVM. And I have small programming enhancements here, or more properly known now as new function APARs. So now that ZVM is in a continuous delivery model, these updates, these new functions are coming out as APARs, which means they will come out as corrective service. Maybe in a year, 18 months, 2 years, they might start showing up on RSUs. Maybe, right? Again, goes to whether or not that how impactful that SPE was, that new function APAR was, to the stability of the system, or if it changed the behavior of the system in a major way, we try to keep those off the RSU. Next release, you got it. You know, that function, you know, the system will behave differently, but we try not to do that in the service stream unless it's absolutely necessary. So that's why, well, you can't assume that these new function APARs will never appear on an RSU. They might. So servicing the system is not just a typing exercise. You need to go out and study the content of the RSUs. You need to see if it has something on it that looks, oh, that's one of those new function APARs. I need to look at that and see if that's going to impact me operationally. Might it have a performance impact? I don't know, but I need to study it before I do it. I always recommend that when you're sitting down to do service, you find some quiet time and you're studying the RSU contents, you're seeing what the deltas are. It's easy with the web pages to find out what's new in an RSU, the new service levels that are on it, then looking into the content of the service level and seeing what PTFs are in there. And also these days going to the ZVM new function web page to see if there are PTFs available in there, new functions that you would like to have while you're in the middle of a service process. Bring them in at that point in time so you don't do it more times than you need to. And then we look at virtual servers. So I've got my ZVM system, and I'm doing the ZVM system lifecycle so that it's stable, so that if somebody says, I've got a new LPAR, we got a new LPAR, yay, I can put it out there. I know what to do. I have a procedure written down. If I'm sick, somebody else can do it. I need to write these things down. Don't assume that you're going to remember all of this. But when you move into the virtual server world, these are things you do a little more rapidly. At least we hope you're doing these things a little more rapidly, because it indicates as you're deploying virtual servers, your systems are growing. And one of the things as you start this process, to start out with things like naming conventions. Coming up with a naming convention on your 100th virtual server, it tends to be rather disruptive. And things like, I know that this is a Linux virtual machine. Why? Because the first two letters of the virtual machine ID are LX. I don't care what they are, but make sure that, because some people say, well, I need to convey a lot of information in 8 characters. I get it. I might want to say, well, first of all, it's Linux. Maybe I already know that. Maybe I have multiple distros. What distro is it? What release level is it? Is it an app server, a database server? Is there some importance I can attach to the virtual machine name? Can I tell what color it is? I mean, they're just, how do I flavor my virtual machines? And if I can express that flavor in the virtual machine name, that's actually a good thing. But how do you provision? So I'm going to figure out what I'm going to provision, but how do I do it? How are you going to add, change, and delete virtual machines? IBM always recommends that you have a directory manager like Dermate. It's really easy for human beings to make mistakes in the directory. And making mistakes in the directory, the control program, CP, typically figures that if you're smart enough to update the directory, you're smart enough to know what you're doing if you're overlaying DASD. Or have many disks overlaying critical parts, you must know what you're doing. And if you decide then to format that disk, and that's a critical part of the system, there goes the system, right? So CP assumes a certain amount of knowledge by the system programmer, and we can insulate, if you will, or provide a layer of protection between the system programmer who's in a hurry, because deadly things happen mostly when you're in a hurry. And directory managers, one thing about computers, they just do what they do. They don't really care whether you're in a hurry or not. They operate at the same speed. So, whether you've got some sort of cloud provisioning tools, whether you've got IBM Wave, all of those push on a directory manager of some sort because they need automation behind this. So provisioning, again, that's a procedure. You can say, I trust somebody to do Dermate. I don't necessarily trust them to edit the directory. So being able to delegate, having these procedures with a directory manager lets you delegate things to other people. People who might be less knowledgeable than you, and you go, well, they have certain restrictions in what they can do. I've set up some front ends to make it easy for them. Not a lot of heavy lifting on my part, and they can go about their business and leave you alone as the system programmer. And with virtual servers, we also need to understand operationally. ZVM comes up, and all of a sudden you realize ZVM and its Linux servers, if you haven't been part of a distributed system deployment, x86, whether virtualized or not, doesn't really matter, but understanding how a virtual server fits in to the entire ecosystem. How do we start them? How do we stop them? Do we pause them? Sometimes clients have the ability to pause their virtual machines, or we need to move it. Server. In the olden days, we say, well, the server, and one of the reasons that virtual server mobility was created, because we had the problem, we said, this rack is getting overloaded. I need to move the server. Utilization has gone way up. It's getting hot, literally. Heat is rising inside the frame. I need to move it somewhere cooler. And so figuring out how do you move a virtual machine? We'll talk about live guest relocation, but then our older technology called dead guest relocation. Okay, so even understanding how do you move a virtual machine from one LPAR to another, that's basically it. And it needs to be a procedure that you can practice and that you can follow, because if you forget something in moving a virtual server to another LPAR, it doesn't work. And you're left going, I forget, what did I leave out? What didn't I do? What was I supposed to write? I didn't write it down, darn it. I knew I would remember. All right, in real resource management, this is another pillar we look at, because how does my ZVM system get resources to give to virtual machines? We're talking about memory, CPU, storage, and with storage, whether I'm talking about Fiber Channel, whether I'm talking about FICON, understanding how are we going to add resources, particularly I/O resources, and that could be compression, that could be crypto, that could be, all these things. How are we going to make dynamic changes to the partition configuration? How do I bring new things into my LPAR? When you're starting, it's really easy to say, we will just bring all these servers down because I have only 6 of them. Only 6 virtual servers inside my ZVM LPAR. I will do it on Sunday at 2 a.m. And that's great because everybody who uses those is in, say, 2 time zones. And then you have 12, and then you have 20, and then you have 30, and you realize people around the world are using these things. And what is a good time to take a virtual server down that somebody else is using? The answer is never. And eventually you realize, oh, well, my Sunday is somebody else's Monday. And not everybody has Saturday, Sunday as their weekend. And then you say, well, I want to take the whole machine down. Well, now you have issues regarding, I got to get everybody to agree to taking all my virtual servers down. Where you eventually end up, and you go kicking and screaming or you go willingly, but eventually you get to the position where you have to dynamically change the LPAR configuration. So understanding things like HCD and is ZOS present or not? How are we going to make dynamic changes to the partition without bringing it down? Do we know how to do it on the HMC, and do we know how to do it with HCD for I/O? When I get new firmware, when I get new hardware, typically with new firmware upgrades, I need to apply the new firmware, and it's going to take an outage. Is it going to be a concurrent upgrade to a piece of firmware? Like to an OSA card? It's going to be a concurrent upgrade, crypto concurrent upgrade. What is the impact? I need to understand when I'm putting a new bundle on, when I'm putting an MCL on, as these things are happening, how is that service going to go on in the hardware? And sometimes you need to get the CSRs involved to help you. You say, well, this thing's going to go on concurrently. I'm a risk averse to concurrent upgrade because it's liable to do multiple things at once, and I want to do one thing at a time. Yes, it's going to be slower, and I know that my grandfather did it that way, but he got through his career just fine. So I have to at least think about these and understand what the impacts are. And maybe this is a case of asking my friends, so how did it go for you? So having a social support network for doing these kinds of jobs is very important. That's why we like the mailing list, IBM Main, IBM VM, Linux 390, being able to say, did anybody put this on? And this could be hardware change, or they could be talking about PTFs and RSUs. This is my environment. I want to do this. Has anybody else seen a problem? So, and understanding that, well, how do I go about this? I want to manually take my chipids offline and online. Oh, I didn't even know I had to do that. Okay, so understanding how firmware upgrades are applied, I want to do them myself. I don't want the machine doing them for me. So knowing that I have to call somebody, I have to get an IBMer in to help me do that. Do I understand what it means to do storage migration? It's great. I just got this thing. I've got storage DASD out there, and it doesn't matter whether it's FICON or whether it's Fiber Channel SCSI. Everybody goes through storage migration. Okay, I bought new things and I want to use them, and I have to get my data off the old thing to the new thing. Waiting until the last month before the old storage device is coming off lease is not the time to start thinking about this. So whether this is a case of, my shop is so poor, we actually have to shut down, the systems have to go on sabbatical, and we have to take our services offline from our clients because we're going to shut everything down and copy the storage. Or, no, I'm bringing in TDMF, I've got ZOS, I've got all this nice stuff to let me do concurrent copies of my storage. In the fiber channel world, I'm working with my storage admins to do concurrent copies, and whether it's flash copies, whatever the vendors are providing, to let me have storage copies as quickly as possible, and then looking at, oh, good, I got a copy. Now how do I start using it? Okay, and different answers for different operating systems. And these real resources, being real, actually have problems from time to time. Virtual resources, I love virtual cables. Virtual cables are really hard to kick. They don't typically catch fire. There are no power supply problems with virtual cables. Real ones, however, have problems. We always like to joke about our tape libraries. There's a specific alert code called smoke in enclosure. And it's always, gee, I wonder why they invented that. Well, there are motors in there. There are fans in there. There are things in there to keep them cool. Good news, we're on virtual tapes these days, but the real ones could actually catch fire. It's been known to happen. Storage devices, DASD, you hear all the springs and you hear bang, like a cartoon, and the thing stops working. Usually, depending on how quickly fatal that was, they have time to scream for help. Okay, and they send messages to the operating systems. Something horrible is happening to me. What do you do with that information? Ignore it? That's probably not a good idea. Okay, the good news is that things like storage devices tend to be able to also alert them. We monitor storage devices or servers, and we monitor them like we would an execution host, right? Not a storage host, but a storage host has a lot of sophistication. So hopefully you're not the first person to have noticed that there's a problem going on. The storage admins themselves should be getting that information. But what do we do with that information? So, I need to monitor. We will get into automation later. In the ZVM case, when a storage device has a real problem, the operator gets a message. A lot of in ZVM, We tell you a very complex thing, and at the end of the day, the operator gets a message, all right? And so watching the operator's console is something that humans used to do, and we end up today using automation to do that for us. Critical to the success of a ZVM system is looking at the pillar of performance. And I don't necessarily mean, oh, it's running slow, go fix it. That is one part of performance management. First of all, how did you know it was going slow? And how do you know then what to do to make it go faster? Maybe your instincts aren't going to give you the right answer. So understanding how ZVM does what it does, hopefully not in excruciating detail, but understanding how it performs, reading papers that have been published on the subject of ZVM performance is important. But I'm going to tell you that you cannot manage the performance of ZVM by observation, okay, or management by query. You don't sit there every hour, I'll run over and issue a query command, or in VM's case, an indicate command. Or there are some that are queries I should issue, and then other things that are indicates I should issue. And how do I recognize something that is a value I don't want? And what do I do to make it into a value that I do want? So performance management is not just about real-time issues. It's also looking at historical data. And why do I need historical data? So I can look at how things today are different than they were yesterday, which is different than last week, different than last month. When people say, when do you need a new machine? If I gave you a new machine, what would you do with it? It's going to cost a bunch of money. Managers will say, if we hired 6 new people, what would you do with them? Is probably not a good answer, because you won't get new people. So understanding how close you are to the edge, to the capacity of the machine, and understanding based on the rate of growth of your workload, when are you going to run out of capacity? When do you need something new? When you say, look, this is a 6-way machine, I'm at 580%, and that's the spike. Yeah, normally we're at 500%, but we're spiking to 580. And by the way, that's when our clients are doing their most important work, so it's an important spike. It's not just, oh, don't worry about it. So understanding, is it a spike, or is that in fact the average daily running? And if you don't have good performance capture, you don't have data which you can look at, you have no information. And people with no information make bad decisions. Watching performance advisories, the red alerts, or Bill Bittner posts something. Pay attention when he talks about performance, or Dr. Brian Wade, when he posts something about performance, it's important to look at these things. And whoa, there we go again with the threshold and status alerts. So if you have tooling, you have monitors, why monitor something if you're not going to look at what it says? Don't collect data that you're not going to look at, right? Our lawyers tell us, don't keep things we don't need. So when does it need human attention? So again, we will see that automation is part of this, having performance management. And how do we do this? We do this with tools from IBM, the Performance Toolkit feature. Hey, it's got a 3270 interface. It has a web interface. Being able to look at the data. If I have other systems, and what are the odds that ZVM is the only server an organization has? That's pretty low, because it's typically not the first thing I'm going to buy at a startup. Not that it hasn't happened, but particularly if the other parts of the organization have been well established for a long period of time, they might have an enterprise-level performance monitoring and management system. And OmegaMon from IBM, it happens to be an example of one of those. Hey, that works for AIX, it works with Linux on x86, it works with Windows, it works with Solaris, it works with lots of stuff. And you say, I'm bringing in another machine. Guess what? Integrated into OmegaMon. But I don't want it shut up and integrated into OmegaMon. Okay? And by the way, you're going to need Performance Toolkit to help it do that. But it might be even, IBM isn't the only one offering it. So ZVPS from Velocity Software. I mean, the point is that at the end of the day, you need to go through the checklist and say, I have tools to help me monitor and manage performance. As many of you know, I'm a security weasel. Okay, and what that means is that I'm really picky about security. So in the security space, it is one of the things that is important, particularly, you just have to pick up the newspaper, pick up Facebook if you follow New York Times, Wall Street Journal, whatever. At least once every 6 months, we get to hear about another breach of some sort. And the important part is that I like to keep my friends out of the newspaper, out of jail. I like to keep them out of the unemployment line. And there are things that we do in the system because we should, not necessarily because I can identify, look, a very specific issue, but we do it out of what is now termed governance. Governance being with a capital G. When I look at systems management, there's actually governance which governs people, it governs machines, it governs processes. It's so that a company can operate in a way that helps insulate itself from defects in the things that it uses, and those defects could be in people. When people do bad things, right? So that's why companies, like IBM, we have all these policies, and we have to get all this education. We have the business conduct guidelines, right? That's part of governance. IBM can go and say, I have a policy that says this. The guy didn't do it. It's his fault. So as part of that is part of why even looking at what I've been talking about is spending money to get various things here. Our clients who are trying to run virtual servers on ZVM do not want to be in the ZVM software development business. That is a line of business. If you say, I can do it myself, you guys are going to charge me what? I can code that. Well, sure you can. Okay, there's these products that people buy, don't do anything that you can't do yourself. It's easy once you know how, but it's a forever investment. And people who are doing virtual server deployment need their system programmers focused on that. How to do that better, more efficiently, how can we get more, doing system programmer things rather than programming, application programming. And security is one of these spaces. Everybody tells me, I don't need to worry about security. I have only one person who's the systems programmer for a ZVM system. And I go, I don't care. Because if your ZVM system programmer won the lottery tomorrow and disappeared, ghosted you, somebody else will have access to those systems. The system just doesn't evaporate because you lose one person. And usually there's at least two people. Me and my manager have access. I'm sorry, that's two people. So now I need accountability. All right, so that moves us into the security policy. People want to ignore security in the ZVM space, but they need a policy. What is that? That's a roadmap. A policy doesn't tell me what commands to issue, doesn't tell me what statements to put in a configuration file. It tells me, how am I expected to run this system from a security perspective? What do I need to do? Just tell me in English, write it down for me, what it is, security people, my security policy people, people who don't know ZVM, people who may not know ZOS, they don't know a particular operating system. What they know is what lawyers need in order to properly manage the legal risks to the company, right? If I don't have security software and I have a breach, whose fault do you think that will be? The company's fault, right? The company will have nobody to blame but themselves. They can't point to a vendor and say, well, I installed the software, but there was a software defect. It was their fault. So the policies tend to say how we're going to deploy this. Are we going to use multi-factor authentication? Everybody talks about multi-factor authentication. You're going, I don't know what that is, so I'm going to ignore it. Well, that might be okay, but it might not be. What is the minimum length of a password? ZVM system programmers don't invent that on their own, right? And somebody says, well, it has to be at least 15 characters, and it has to have mixed case, and it has to have a special character, all those things. By the way, you can't do that if you're not running a security manager on ZVM. Otherwise, you have 8-character uppercase passwords, and that doesn't meet the modern requirements. So again, this is a document or something that you can infer from existing documents. This isn't necessarily a separate document, but this is saying, what are our IT requirements? Okay, why does my Windows password, why is it the way it is? Why on ZOS are my passwords the way they are? Something is driving that. So you have a policy, and you follow this up with an implementation guide. And the implementation guide is the thing that is very ZVM specific. You need one. Why? It shows me what done looks like when I'm deploying a new ZVM system. And if the policy changes, then the implementation guide changes to go with it. When I sometimes do find that policies will sometimes have some product specificness, and they'll say, well, you have to use the foo facility. And I go, that's something that's very specific to Windows. It's part of the Windows operating system. So we have other operating systems here. So what were you trying to accomplish with the foo facility? All right. So sometimes you want to be careful that you do sometimes have to go back to the security policy folks and get them to change that. Okay. Otherwise, you can conceivably lock out a ZVM system for participation. Oh, you can't conform to the security policy, so we can't use you. That can get you into trouble. So again, you want to find out about this, Not in the month before we go live and somebody says, we need to get the security folks to sign off, remember? And here we are 1 month and they say, do you have the foo facility? No, I don't have that. Well, then you can't deploy. What? I said you can't deploy. And now you're scrambling, trying to fix something you should have fixed a year ago or 6 months ago, right? Well, we want to deploy, we don't have ZVM. We don't have Z at all. And we want to put this in here. Well, let's start a conversation in all of these pillars. Okay? And I would say that, somebody says, well, we have VMware, and I have a policy about VMware. I'm telling you, VMware is full of things that ZVM doesn't have in it. We have an equivalent to those things. Okay, so I say, well, we have the separate virtualization policy, and you read in it, and everything in it's all about VMware. You say, well, before we deploy, we have to go work with the security policy folks, and we have to work with them to get a new document, either one that has ZVM-specific policy, if that's how they want to go, or let's take this one and rewrite it in a way that says, oh, multiple operatings can fulfill this. So, that's just the policy side of things. And then operationally, looking at provisioning, being able to understand that when I'm provisioning something, what am I provisioning? How does it fit into the security policy? Because I have things that I trust, things that I don't trust. When I'm provisioning virtual machines, am I provisioning for a human, for a new administrator? Am I provisioning for Linux workload? And just because it's Linux doesn't mean it's Linux workload. We have Linux servers that operate as part of the system management infrastructure. Okay, and they're going to have different requirements. So I have to be careful. Say all Linux servers will blah, 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 whatever. I need to be very careful about that, or again, I will paint myself into a corner. So knowing what a server does might decide, well, in what group does it belong? Because when I put a virtual machine in a group, all of a sudden it has a set of privileges, a set of authorizations. And being a member of a different group could give me different authorizations. But understanding, too, that in the security world, what do I do when the security administrator is not available? I have an emergency. How do I break glass? It's called a break glass process, and it's part of the configuration guide, because the policy should actually give you the ability to say, we have the concept here of break glass. If you raise a request with the security admin people, not the ZVM people, not the Z people, okay, but the security people, there's an ID on your system, and we have the password kept in a vault. The vault is buried underground in an old missile silo, okay? So we have a place where we can go and get the password, and you can log in, and that thing will be very highly privileged, and we got people looking over your shoulder while you're using it, okay? So you can get out of a problem. But understanding that things happen. If you have a security system and it has a database, like a RACF database, what happens if you lose the DASD volumes that the databases live on? RACF is going to get upset and start prompting the, guess who, the operator for permission for things. Well, wait, I don't have human beings sitting there watching and answering questions. And then the hypervisor gets tired of waiting, and then its final answer is no. Because when in doubt, the answer is no. Okay? So then things start going wrong, everybody's getting confused. So I need to understand how I'm going to deal with emergencies. RACF is down, how do you log on? There's a way. Okay? It's easy once you know how, but you have to know how. And the different security servers, different brands, whether you're doing RACF, VM Secure, ACF2, Top Secret, I don't really care as long as clients have one of them, right? And the procedures around these things are going to be different with each one of those brands. So even we're down to what do I audit? People ask, well, you have to audit all the privileged things that a person does on the system. Do you know what all of those are? Do you know how to find out what all of those are? So what do you audit? How do you set it up to audit? How do you detect configuration changes? Is that something you are required to do? You might not be required to do it, but you might think, hey, actually, that's a pretty good idea. I would like to be able to compare configuration files from last week to this week and find out if something changed. Turns out I'm lucky, and I have 18 system programmers. Just kidding. That wouldn't really happen. But, I have several people, and I have some of them that are new hires, and I would like to know if somebody accidentally, maybe they didn't intend to change something, but I'd like to know if something's been changed. And then penetration testing. This was a thing back in the late 70s, early 80s, penetration testing. Everybody was talking about that, and then they quit talking about it. Well, it's back. And some institutions are required to perform penetration testing against their own systems. while ZVM is hiding around the corner. Everybody's trying to keep their ZVM system hidden. If I don't show it to anybody, nobody will know it's there, and I won't be required to do this. But that could come up. And then an aspect of security with data. We're talking about this. This is pervasive encryption kinds of stuff. Figuring out, I've got TLS. I do not telnet into my system without TLS. It's configured to prevent it. Okay? So, and then at rest, my DASD volume is encrypted. And different virtual servers can have their own, Linux does its own encryption. Resource access controls. You know, I want group-based memberships. I don't want to be granting individual servers rights to specific things. Basically, I want to color code a virtual machine. You know, blue virtual machines have access to this, red ones have access to that, green ones have access to that, and all I have to do is change your color or just say you don't have a color anymore, and you can't access anything, right? And then as you deprovision virtual machines, you might have, how do I clear or purge or destroy, depending on what I need to do, how do I get rid of that residual data that's there? And the procedure I follow might depend on what kind of data was it. Was it PII? Was it personal information, or was it sensitive information, or was it just information? Was it an operating system files? You know, so that might go to how aggressive do I need to be with that. Networking. And networking actually will cross over into security. When I'm looking at networking in the system, when I've gone and I said to a client, do you have network training? No, that's too bad, because you're going to get a crash course in networking. Because in order to fully utilize the capability of ZVM, we get into the virtual switch, right? TCP/IP can sometimes seem easy compared to a switch. And I could go out and say, look, in the real world, we have certified network engineers who go out and work with physical switches. Now, you don't need to be certified network engineer to work with a virtual switch. It would help, okay, because somebody who's configuring a virtual switch has to work with the people who configure the real ones, because the virtual switches talk to the real switches. And sometimes I need to have those two things be in sync. And so how am I going to communicate with them? We need to be able to communicate in the same language. So sometimes this isn't about capability. I don't have to know how to do a thing. I just have to know how to ask other people to do it. And I know that the ZVM development team here in Endicott fully understands that I'm well aware of that. I don't have to code a line item. I just have to know how to ask them to do it. All right? And they've learned how to say no. But being able to communicate with your peers in networking is important. And if your background is ZOS, ZOS doesn't have a lot of these concepts. And so, therefore, these will be new. You know, when I talk about channel bonding, when I talk about link aggregation, okay, those are concepts ZOS doesn't have in it. Linux has them. Okay, a lot of operating systems have them, but ZOS doesn't. So we have new things to learn there. I need to understand hypersockets. I need to understand the security characteristics of hypersockets. I need to understand the security aspects of a VLAN. And I'm talking about an IEEE VLAN on a physical network device, not a ZVM virtual LAN. And bridges, we have something called a hypersocket bridge. What is that? Well, I need to study the ZVM connectivity guide to do that. So some of these things are get some education first before we start planning things. So let me understand what I want to plan. And planning, by the way, involves pencil and paper. It involves or some colored pencils. Okay? I need to draw things in order to plan a network. If somebody has a problem with their network and they ask for my help, the first thing I ask for is a diagram that shows me their network. Okay? The tail of the blind man and the elephant, right? I don't know what I'm looking at if you just show me a configuration file. I can't see your network from a configuration file. If you say, is this right? I don't know, because I don't know what the network looks like. And this has to match the network. So some planning. Understanding what my bandwidth requirements are. Will one OSA moving data in and out of my system be sufficient? Or do I need more than one? I'm not talking about high availability here. I'm just talking about bandwidth. All right? So I need to understand what the capacity requirements are going to be, because that drives what hardware I'm going to need, how much of it I'm going to need. And the more hardware, networking hardware I have, the more cables, Ethernet switch ports, switches themselves. Do I need more of them? How much power do I need? I'm going to need more power to bring in more switches, right? Because that corner of the room is out of power. And then these things have physical components. Physical components fail. How do I know when there's been a failure? Nice thing about high availability configurations, you don't notice when they fail over. That's nice. It failed over. My applications are perfectly happy. Linux is running just fine, not complaining at all, didn't notice a thing. I've now lost my high availability. all right, because I've lost one. I have two of everything. I lost one, everybody's happy. Did you notice you lost one? What happens when you lose the next one? So understanding when elements go down. And when people say it's running slow, it must be ZVM's fault. Because it's the first thing out of people's mouths. It's ZVM's fault. It might be, but in the networking world, it turns out to not be very likely. Okay? There are a lot of things that go wrong in a network, and being able to analyze what's going on in the network is an important skill. Again, being able to communicate from a ZVM point of view, being able to talk to a network engineer and being able to communicate in a common frame of reference and ask for help. Sometimes people in the Z world like to do everything themselves. You cannot solve a networking problem by yourself. Okay? It just doesn't work that way. By all means, you can look over your configuration and see if you did something stupid. Do that first. But once you figure out, look, I've been looking at this thing for 2 days and I can't find the problem. You spent 24 hours too long looking at the problem by yourself. And understanding that just because it's valid configuration doesn't mean it's a wise configuration. You know, so when I actually recommend to clients about how do you configure the virtual switch, I have very specific recommendations of the things to use. Okay? I don't want them just kind of, oh, well, I'll use this default. Why? Because it's the default and I don't know what that keyword means. Okay, so I'm going to just leave it alone. Well, no. Let's study. Maybe there's a keyword you do need to use. Okay, so making sure that you go through a configuration review. When you go in, putting in a new LPAR, when you go into a new configuration, we're going to a new machine, always stop and think about, well, you know, on my old machine, I made sure that those OSs were plugged into separate switches. We moved data centers, and I need to ask, I know that it was there, you know, 5 years ago, we said this, but was it obvious when we moved to the new data center that people made sure my OSs were still plugged into separate physical switches? All right, so an awareness of the ecosystem in networking is important. And looking at even vulnerability assessment. If I'm doing TCP/IP administration, VM TCP/IP stack administration, I know that there are security alerts, vulnerability alerts that come out, and I need to figure out whether I need to get those patches on. It's easy to forget about the Rocky cards. Okay, if I'm using SMC, Linux communication between, say, Linux and ZOS, or between two Linuxes, and they use the Rocky card. Okay, and making sure that I understand it, I understand how it fits into my network. ZVM itself might not exploit all the pieces of hardware, Rocky being an example of it, but the guests are doing it. So out of sight, out of mind, make sure you don't lose sight of the resources from a networking point of view. Well, in general, don't lose sight of the resources that the guests are using that ZVM itself is not. So Z, zero downtime. It does not because of just the componentry, right? Yes, very high quality componentry and high availability is what we get when we assume that a component fails. You have a single component failure. The single component could be anywhere from an OSA card failed. Well, we've got FICON channels. One of the FICON channels failed. A switch port failed, right? And I need to have redundancy. Redundancy is another word for high availability. I need to be able to have other ways to accomplish the same goal. If I've got FICON, I need to make sure I've got more than one cable running to multiple devices. I've got a FICON switch. If I'm switched FICON, I need two FICON switches. I need two of everything. We don't do anything by ones because if you have one, it's guaranteed to fail, all right? And mean time between failures is not how you drive continuous availability, right? I'm just buying the best components I can. What that does is actually just reduce the odds of a single component failure, but you will have a single component failure. It's simply mean time between failures. That time goes way up, okay? Better components you buy, the more reliable they are, but they do eventually fail. So, or maybe it's not an unplanned outage, it's a planned outage. The people who work on the FICON switches, the people who work on storage servers, the people who work on Ethernet switches, those components do go offline. I've seen during the night, Ethernet switches, they'll just apply a patch and then it's a rolling reboot of the switches. And you go, it was only connected to one switch. Guess what? I lost all connectivity while that happened. Yes, I understand it was only a 7.5 minute outage. But all the alarms, all of my alarms went off. The monitors said, I can't reach the Linux server anymore. Oh, I forgot. It was a planned outage by them, not by me. okay? I wasn't in the loop. So you need more than one. And oh, by the way, humans are a component of the solution. So when I said you have only one system programmer, don't do that, okay? You need two. These platforms, you have to invest in order to be successful. And investing in the human element is important too. Clusters. Clusters, whether it's an application cluster, a database cluster, a hypervisor cluster, server cluster, storage clusters, I need, again, more than one of these things because they do fit. When we're looking in the Z space, one of the things we look at is GDPS and Hyperswap. Okay? How do we keep FICON storage? How do we keep ECKD storage online at all times? It's a big investment. But people say, well, that is expensive because I need probably, I've got one storage server, one DS8000. I need to buy two more to do this the right way. I need at least two more. And everybody goes, do you realize how much money that is? I go, how much does an outage cost you? If you lose, if you have a fire in your DS8000, if you see the springs coming out of it, you have a flood, you have the sprinkler comes on. I don't know what it is. We can't, this problem is we can't predict these things. That's why we call them unplanned outages. And you go, what am I going to use to keep the system running? How will it continue to run? You say, oh, well, it won't run. We'll only be down for a week. What did that cost you? Do you have commitments to clients? Do you have internal commitments? Many times I find that in the Z world, we're running workload which is involved in delivering services to their clients. Sometimes those clients are internal. This is an environment where people are doing development for the next iteration of services that I'm scheduled to bring online in 6 months. I can't take that workload away. If I do, I'm going to miss my commitment, and they won't be able to deliver that service to my external clients that I promised. So there are multiple lines of business often running on these Z machines. And when you take them all together, they ask you, what is an outage? What does a storage outage cost? Hey, if it's a little glitch and I'm just down for an hour and I'm back, you go, oh, that was no big deal, right? Okay, you're lucky. Luck works. I can take it. But sometimes you're not going to be that lucky. So sometimes the high availability is because I erased something. Oops. And it wasn't something I can easily type in. Okay. How do I get it back? If I don't have copies, that's great. I have a copy. How did you make the copy? Do you know how to get it back from the copy? At home, I image my Windows machine. I'm not really sure how to retrieve specific bits and pieces off that image without re-imaging the whole thing. No, I didn't really want that. I just wanted bits and pieces of it. Okay? So having software, again, to let you do this is helpful. This is just a picture of what Hyperswap really does. I have a primary and secondary device. These are separate storage servers. Okay? Think of it as a separate DS8000. And one DS8000 is replicating. As I update the primary, as I write to the primary, updates are going to the secondary, and the I/O does not complete until both of those are done. Now, that's a local operation. Okay? I can do that very quickly, and the I/O time does not go up considerably. Okay? So, common thing. But something goes wrong with the primary. I can immediately switch over to the secondary, and this is something that GDPS manages the Hyperswap process. But this ensures that ZVM continues to function. If ZVM goes down, I lose all the servers. I can have high availability in my Linux servers. From a storage perspective, I have high availability there. If I don't have high availability for ZVM itself, I'm going to lose all those servers anyway. So in that case, you need a way to have storage availability. Now, we have our single system image. That doesn't help you with storage availability. What single system image does is help me with the idea that I'm going to have a planned outage of a ZVM Altmark. Okay, that's one of the things it does. One of the other things that single system image do is to let me move workload to where the horsepower is. Okay, sometimes the workload, I said you've been monitoring the workload in this one LPAR, and it's going up and up and up, and I was at 500% on a 6-way. Well, we brought in another box. It's a 10-way. It's got more capacity on it. We hooked it in because I've been planning to do this. It's not an emergency. I've been planning this for 6 months because I've been watching the performance. I knew I needed new machines. Now being able to hook that up, being able to have an SSI cluster because I planned for it, and then being able to move that server, virtual server, over to a machine that has the horsepower to accept the workload. Now I can increase the workload on that. I'm not going to max out. So a single system image, I can put Linux servers when I deploy them where I have capacity. Then I can decide to change my mind. Okay? and I can change my mind without bringing the Linux service down. It's just part of an availability. It does not exempt you from having Linux clusters, application clusters, database clusters, right? Because what if there's an unplanned outage of the ZVM LPAR? It takes all the Linux servers with it. I don't know when that's going to be back up. What am I going to do? I really need to have had my Linux servers clustered so that they continue to operate. The service is available, even if I lose one of the components, right? Where a component can be a server. And all of this goes up even to what happens if I have a KEC failure, a CPC failure. What am I going to do? Do I have another place to run this workload locally? Or do I have to clear a disaster? How long does it take me to get back up and running in a disaster scenario? Because those are going to be slow. I don't know. How fast does it need to be? All right. So disaster recovery is a different beast than high availability. High availability says I had a single component failure and I was able to recover from it very quickly. Okay. And I have a standard for how long that has to happen. How long am I allowed to be out if I have a single component failure? It can be 5 minutes. I have a client that they have a system that the whole country uses, part of law enforcement. And if that system goes down, if it's out for a minute, the watch commander, data commander, it gets notified. Okay? If it's out for 5 minutes, the director of the agency is told. In 15 minutes, the President of the United States will be told that there's a service outage. And ZVM is part of that. Everybody gets scared when you bring something new in and going, what are we going to do? And more of the states are switching from going to the ZOS side of the house to interact with the database, going to the ZVM side of the house to talk to the database, okay, which lives over on ZOS, but I'm coming in through some transforms on Linux. And so being able to understand what my requirements are for high availability, how much money am I willing to spend, kind of depends a lot on what is the impact of the outage. What did it cost you? That cost can turn into a lot of different forms of payment, all right? But disaster recovery is what we engage when I think about it, saying I didn't have a single component failure. I had multiple components fail. That's lose a data center. If I lose a CPC, I've actually lost memory. I've lost CPU. I've lost network connectivity. I've lost a lot of things in addition to the service. Those are resources I can't use. What resources do I have available to run my workload? I still got to get work done, okay? So sometimes I have a disaster recovery machine that's a quarter the size of my current machine. How's that going to help you? Can you live with a quarter of your workload? Well, I can for a couple of days. You had a fire, okay? We have to rebuild the data center. It's going to take 6 months at least to get this there, okay? And it won't be like it never happened, okay? It will happen. So when that does happen, you have to plan on being in your disaster configuration for a long time. Can you do that? Do you have a plan C that says, well, my contract for my disaster recovery site limits me to 30 days. Am I prepared to pay for the additional 5 months? Do I have a rainy day fund? Do I have another place I have to move to? So understanding that. So if you lose your site, what are you going to do? If you lose a lot of componentry, what are you going to lose? In this case, we talk about from my storage backup. These are cases when I need asynchronous copies. Okay? And somebody says, I need asynchronous copies. Really? How asynchronous is that? How old is the data allowed to be in my disaster recovery site as compared to home? Now at home, my copies were synchronous because they were right next door. Okay, I can't do I/O between New York and Los Angeles synchronously. I can't do it. The speed of light is a problem. We have our best engineers working on to break the speed of light. If you heard quantum computing, I'm hoping they're going to do that. All right, but I'm guessing speed of light will still be a problem. So we have to do these things asynchronously, and what that means, there's a lag in the data. How back level is it allowed to be? How old can it be? And the more resource I put in to getting, how faster the links are, the more money I spend on them, the lower that latency will be. So in these cases, figuring out how do you switch sites. So what is your procedure to switch sites? You have to know what it is. In the GDBS world, we call this a region swap. You know, and one of the easiest things to do is the little light is sitting there flashing saying, do you want me to swap regions? And you say yes or no. You say yes, the whole thing goes automatically. Well, does it need to be automatic? I don't know. How big is the environment? What is the opportunity for error? If humans do it, how long does it take? because there's a maximum amount of time you're allowed to be out. Some people have contractual arrangements with their clients that say, if you're offline for more than 4 hours without an agreement from us, it's going to cost you $1 million a day. All of a sudden, the cost of an outage, the price of these things start to look better, right? And people even know how to fail over. What they don't necessarily know is how to get home. They've learned to fail over to another site, and they say, okay, problem fixed, let's go back. I don't have a procedure for that. Well, your lease is about up here at the disaster recovery site. Let's think about that. Let's practice that. Too late, right? So disaster recovery, a major component. And we help retrieve a lot of this stuff we've talked about so far through automation. And for ZVM, this is a lot about the system operator console. A lot of stuff it puts out is just what I call tourist information. Somebody logged on, somebody logged off. I don't really care, okay? I do care if it's telling me I've got I/O failures, right? I do care if there's a security alert showing up, right? Sometimes it's a prompt. It's not just informational. The system is asking for action. How do you deal with that? Okay. So typically, we don't run software in the operator virtual machine, but we watch the operator's console, okay, with other software. And then we see those things and we can react to them. You can't really run it inside the virtual machine, inside the operator, because sometimes it's CP asking a question. When CP asks a question, the virtual machine can't answer it, okay, because the virtual machine is interrupted. So I have to look at the monitoring from the outside. I have to consider how am I going to record console logs? Do I need to? Well, the operator, I certainly do. Other virtual machines, well, we don't keep console data in the spool. The spool is not an infinite supply of storage. It will run out, and then you have to manage that. So how are you going to deal with that? Sometimes you have to be able to generate alerts, enterprise-level alerts. This is stuff that I've had a problem, and I need to tell my central monitoring infrastructure. This is integrating into your existing infrastructure. A new server goes in. There are things that have to be added into the monitoring infrastructure so they, whomever they is, they will be able to see, your system will have visibility, and they will see that when it goes yellow, when it goes red, and they'll be able to call out somebody, because there will be a process that says if this system goes red and it's been red for more than 5 minutes, then there's a procedure that gets invoked. That may be automated as well, right? But we can use automation for a lot of different things. I can distribute files around if I wanted to, coordination of flash copies, backups. How do I start up, shut down my system? I mean, we think of some things as the profile exec, that's automation, okay? It's real simple automation, but it's automation nonetheless. So that alert management. So I said, well, something bad happens on your system, you need to send an alert. Sometimes it's performance. There's been a performance problem. I need to get the alert off the box. Nobody's watching my ZVM system console. It's a weekend, or everybody's on holiday, except for the one poor soul who has to stay home. But, I've got the hardware is warning me there's a failure starting. I'm detecting a problem. Somebody needs to know. A user has been revoked. Maybe I don't care. Oh, wait, that was one of the system administrators got revoked. I need to tell the other system administrator, Bob had a problem. And how you do that? Well, how you do that depends on what kind of event management software you have. It can be simple as using SNMP traps. If I don't know what those are, I need to ask, okay? Or it might come from my system management field, say, well, you can just send us SNMP traps. Oh, you need to forward us a syslog. Oh, well, IBM Operations Manager can generate a stream of data that's in syslog format, So do you have software to do that? Or do I need to generate an email? You can go old school, you go new school, right? So that's part of integration. I also need to think about operations. These, again, are things I don't do. Do I know how to IPL the system? I get calls from clients. Last person who IPL'd the system no longer works there, all right? And new person calls me and says, I think I need to IPL. I'm standing here in the machine room, in the cage. I went down to our shared data center, got access to the cage, and I have this display in front of me. What's that? I don't know what it is. Well, then don't touch it. Too late, I've already touched it. So understanding how to log into the HMC and not the support element, okay? Understanding where that's located, having an ID to be able to do that. What are the load params? What is SAPL? What are the IPL parameters? How do you set the defaults for the IPL parameters? When should you shut down versus shut down re-IPL? It's always a good question. You've got a problem, you're on the phone with the support center, and they say, get a snap dump. You start snapping your fingers. And that's not what we meant. Okay, so how do you get a snap dump? What do you do with the results of a snap dump? How do you deal with dumps? They say, well, we're going to need a restart dump. Again, terminology is very important. How do I get a restart dump in the system? Okay. By the way, not everybody knows what system restart means anymore. That's an old school term. Okay, people who know the architecture recognize it. Folks today don't really necessarily have to learn the architecture before they learn. I studied x86. I won't tell you what actual processor type I studied in college, but I studied that architecture and I've forgotten most of what I know, but I can still use Windows and I can still do things with it. I don't have to know those things. Okay, and really, we shouldn't have to know how the hardware works in order to manage the software on it. But that said, software invented back in the day when that was a requirement still exists, okay, and still carries that forward. So some knowledge of the architecture is important. How do you get a standalone dump? I tried to IPL, the system won't IPL. I tried to shut down, the system won't IPL, it won't shut down. I don't know what to do. Support Center says, well, you're going to need to do a standalone dump. What is that? How do I do it? Well, when you installed the system, you ran this program that pre-prepared that. No, I didn't. It said optional in the book. Well, okay, it wasn't really optional. Okay? And so you need to practice these things. You can practice this stuff second level. Second level. Aha, got you there. You need a second level system to do things. Okay? You need a place to play. Again, on the HMC, I need my own ID. We don't share IDs. You don't log on to sysprog. You have your own ID so that you can't be blamed for doing things to other people's. People can find out what I did. Oh, I don't need OSA ICC. I don't even know what that is. Well, then find out because you got to have it. Okay? They're cheap enough to add. When the KEC is IML'd, when you go through a power on reset, does your ZVM LPAR automatically start? If it automatically starts, does it automatically boot? Does it automatically IPL? Well, I certainly hope so. Otherwise, human beings have to be called to do things. You say, well, we have staff that does that for us. Why? That just means now, when you're in a hurry, you got to get the right people. The system can come up on its own. So having those kinds of things configured. Or when ZVM itself IPLs, does it stop and prompt you for what time it is? Okay? Or does the system say, do you want me to do a warm start, forced start, cold start? Say, no, I've already got that configured. Just come on. Do I gather data I'm not going to use? Error, off. Symptom records, off. Accounting records. What are you doing about when do you do backups and restore? Or when do you do backups, really? How often do you do backups? When do they run? How do you assess the success or failure of a backup? It's really bad for your backups to have been running for the last 6 months and failing all along because you didn't notice. Some of these service virtual machines, like Performance Toolkit, like RACF, it collects SMF data. What happens when these disks fill up with old data? Usually nothing very good happens to you. Something stops happening. Okay? The system may keep going, but now you're in now I'm in a problem where I'm not collecting data. That's not good. And then finally, the last pillar is chargeback. Now, chargeback is probably, I'll say, of all the pillars, is the most optional one. The others really require some thought, and you have to address them in some way. Chargeback, I'm willing to say, you can sort of defer looking at this. But why are you deploying servers on Z compared to other platforms? How did you decide, how did you arrive at this is the right place to do it? I understand the hardware costs more, all right? But how did I arrive to, yeah, but it's the right price? So being able to look at what is the unit price? What do we think it costs to deploy a virtual server here on Z compared to something else? Human time, taking account humans, resources, all of these sorts of things. How many virtual servers can stand on the head of a pin? I mean, when they're virtual servers, how many can I get here? Well, I don't know. How much disk space am I associating with them? How much CPU are they using? CPU is one thing you can't virtualize. It really takes real CPUs to execute things. Memory is actually real, not fake. It's real. Some people are tempted to do things like consumption-based pricing. I just recommend here, don't do that. It can get you into a lot of trouble because of prices of CPUs, and then you work out what is the price per CPU minute, and then you start looking at numbers that don't make a lot of sense, and they change from generation to generation. You might end up with a chargeback that says, actually what I'm going to do is I'm going to charge a department $50 to deploy a server. Oh, you want it on premium? You want better storage because you have higher performance requirements? Oh, well, I'll charge you, never mind, I'm still going to charge you $50. I'm not going to do it. But you can have silver service, bronze service, gold service. You can do all of that. And if you get a lot of competition for your system, all of a sudden everybody's going, this is kind of cool. I can get a system in 15 minutes, or I can do whatever. It's pretty cheap. But you might end up having premium charge for premium service. Or you just say everybody gets the same service. Why? Because I'm spending more resources and money figuring out the differences than I would be just do everybody the same as a cookie cutter. High availability, the hyperswap business, I don't want to have to choose which storage volumes I'm going to hyperswap and which ones I'm not. Everybody gets benefit of hyperswap. Okay? It's just going to be the cost of doing business. It's built into the base price. I'm going to charge you $52 instead of $50. Everybody. All right? And just because you know what it costs doesn't mean you actually have to bill somebody. Ideally, this is part of infrastructure. That's the best world, where people are saying, look, we're going to deploy servers. We got clouds, whether they're internal, whether they're external, it doesn't matter. We got to pay for it anyway, right? And if I was going to say, well, we were just deploying in the cloud, there's a corporate bill, no department sees it, it's out of the CIO budget, and you go, internal clouds can be done the same way. So again, cost of doing business. Is it cheaper to have my own cloud internally, or do I want to go externally? Well, it's not necessarily about cost, right, in terms of dollars. Sometimes there are things that are cost, like, oh, I got to meet GDPR requirements in Europe. And not just in Europe. A lot of countries and institutions are adopting GDPR, even though they're not in the EU. Okay? Why? Because it turns out it's a pretty nice set of rules I didn't have to invent for myself. Somebody else is doing the heavy lifting on the rules. All right? So ultimately, there just needs to be a checkbox in all of these because you've looked at it and you've chosen to do a thing or not do a thing. But it demonstrates you didn't ignore it. Okay? And how much you spend in each one of these, which is what then, as you go into the next level of depth, of detail into each one of these, finding out how I do it, that really depends on how important this particular pillar is to your business, right? DVM Lifecycle, that's not about spending money. That's about educating yourself. And I can say, well, education costs money. Sometimes it does, sometimes it doesn't. Sometimes it's just read the book, okay? Talk to your friends. Get that social support for understanding how to do it. We publish manuals, and people like to skip over the introductory chapter. And I go, did you read the introductory chapter? No, it's where we explained all that stuff. You were looking at the command reference. You're way back, whoa, let's back up. All right. And then other things, I actually do need to spend money. I have to spend money on security. I have to spend money in performance management, high availability. Disaster recovery is going to cost me money, right? Because I have to have more hardware. Automation, I'm going to need money because I don't want to be in the software development business. And by the way, if I develop it and then when it's time for me to leave, who's going to take care of it? Okay? I work with clients who hire me to do that stuff. It's forever. I go, cool. You'll pay somebody else to take care of software that you wanted to be homegrown when you could have bought a piece of software that would have done it. And the support for it would have been included already in the price, right? Companies can buy software support contracts much easier than they can buy a custom programming contract. Again, governance. Governance prefers one of those over the other. All right, so if you've got a checkbox in all of these, then you've done the basic part of your homework, and then you go, cool, I see what I'm going to want to invest in, what is the priority I need to invest in these pillars, and then I can move forward.
All right, then. Well, thank you very much, Alan.
Thank you.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.